Lesson 3, Building Your Knowledge. How many organisms can an ecosystem support? Top caption: This ecosystem cannot support an endless number of buffalo. Many factors, including availability of food and water, influence the population size an ecosystem can support. Bottom caption: A natural disaster, such as a forest fire, can destroy or damage a population regardless of the population density. It is a density-independent factor. Organisms depend on resources from their ecosystem. Water, food, and shelter are necessary for survival, but the ecosystem does not have an endless supply of such resources. When there are not enough resources for all the individuals in a population, that population will decrease in size until it is small enough that the ecosystem can support it. The maximum population size that can be supported by the ecosystem is called the carrying capacity. A population's carrying capacity is influenced by many factors. Scientists organize these factors into two groups based on how they are influenced by population density. Population density is a measure of how many individuals are present in a set area. For example, a population that has just a few individuals in a square kilometer has a low population density. A population that has a few hundred individuals in a square kilometer has a higher population density. Environmental factors that affect population size the same way at any population density are called density-independent factors, like that forest fire that we just looked at, or the weather. Environmental factors that affect population size differently at high and low population density are called density-dependent factors. For example, disease. We've seen the spread of the coronavirus had a higher rate in New York City because they live in a high population density area. Every population is influenced by both kinds of factors. Many weather-related features of the environment are density-independent factors. Drought impacts populations because organisms will die if they cannot get enough water. This will lower a population size, whether the population began at high or low density. Natural disasters, such as hurricanes, earthquakes, and forest fires, can also impact population size, regardless of population density. A forest fire will destroy both densely and sparsely distributed plants. Common density-dependent factors in the environment include competition, predation, and disease. Competition for limited resources, such as food, depends on the population density. At high density, there's a lot of competition. At low density, competition is not necessary. Predation has a major impact on population size when there is high population density because predators have no trouble finding prey. But at low population density, predators might not find prey easily, and the impact of predation is lower. Disease often spreads more quickly in high-density populations because individuals frequently come into contact. Thus, disease is a density-dependent factor. Understanding carrying capacity is important because it helps scientists monitor changes in ecosystems and prioritize conservation goals. In managed wilderness areas, it is important to keep populations below the carrying capacity, or they might rapidly decline. Finding new ways to get resources is not easy for many animals. Exceeding carrying capacity forces organisms to find new ways to meet their needs, or it causes high mortality or death. Top caption: access to light decreases with depth in the ocean. This density-independent factor influences the carrying capacity for many organisms that use photosynthesis to make food, like phytoplankton that live in the ocean. And the bottom caption: competition for resources such as food increases when the population density increases. That makes competition a density dependent factor.